Welcome. Today we are going to do prime factorization. Prime factorization is when we, it's page 81 in your math book, is when we take a number and we break it down into its prime factors. So to do this, we're going to use what's called a tree diagram. So let's start with the number 36. So I write 36 and I make some tree branches on it. And I can start with any factor pair of 36. So I'm going to start with 2 times 18. So if I look at 2 times 18, I am looking for the prime factor. So when I get a prime factor, I'm going to circle it. So 2 is a prime number. I'm going to circle that too. But 18 is composite. So when I get to 18, I'm going to break that one down into smaller factors. So I have to think, what are two factors or a factor pair of 18? And I'm going to say that I can make 18 by doing 2 times 9. Again, I have a prime number in that pair. 2 is a prime number. I'm going to circle it. But 9 is composite, so I have to break it down even further. So I'm going to make my tree branches come off 9, and I'm going to think, what is a factor pair of 9? So I'm thinking, and I think that I can make 9 by doing 3 times 3. And 3 is a prime number, so I am going to circle those prime numbers. And then I'm going to write the prime factorization out for 36. So if I write the prime factorization, which would be what the directions would tell you to do. So if I write the prime factorization, I would say that 36 equals, and when I write my prime factorization, I'm going to write my prime factors in order from least to greatest. So I'm only writing the factors that I have circled. So I'm going to write 2 times 2 times 3 times 3. And that is the prime factorization of 36. So let's try 36 in another way. So if I try 36, I can start with a different factor pair. So it doesn't matter what factor pair I start with, I will get the same answer. So let's try it. Let's say that I can get 36 by doing 3 times 12. So 3 is a prime factor. I'm going to circle it. And then I'm going to look at 12. 12 is a composite number, so I will break it down even further by making some branches. And I can make 12 by doing 3 times 4. Now 3 is a prime number. I will circle it. And 4 is a composite number, so I'm going to break that down even further. And a factor pair of 4 is 2 times 2. And 2 are both prime numbers, so I'm going to circle those. And then here I am again. I have all of my branches end in circles, which means that I have finished. And when I write out the prime factorization of 36, after I've started with 3 times 12, I still have to go back and write them in order from least to greatest. So I get 2 times 2 times 3 times 3. So I get the same answer. It does not matter what factor pair I start with. If I break them down correctly, I will get the same prime factorization for that number. Let's do one more as an example. Let's break down 24. Let's find the prime factors of 24. So I start with my branches for my factor tree. And I can start with any factor pair. 24 has a lot of factor pairs. I could do 2 times 12. I could start with 3 times 8. I could start with 4 times 6. So I like to, if possible, I like to start with a prime number. So I'm going to start with 2 times 12 because 2 is prime. So if it's possible to have a factor pair that starts up with a prime, I like to do that. 12 is composite, so I'm going to break it down, give it some branches here. And a factor pair of 12 would be 2 times 6. I could also put 3 times 4. It'll come out the same at the end. So 2 times 6. 2 is prime. I'm going to circle it. 6 is composite. I'm going to put some branches on there. And to break up 6, a factor pair of 6 is 2 times 3. 2 is a prime number, and 3 is a prime number. So now all of my branches end in prime numbers. I can write out my prime factorization. So I'm going to say that 24 equals. Again, I need to write them in order from least to greatest. So I have 2 times 2 times 2 times 3. And that is how you find the prime factorization of numbers.